Alright. So today we're talking about what we call the number e and the natural log. Yes, e is technically a number in this case. So, the number e and the natural log, we've talked about logs, now we're talking about the natural log. So, the number e is what we call the natural base. The number e is what we call the natural base. So that's our first fill in the blank there. It is the natural base and it is irrational. Right? Remember that means it just goes on forever and ever without repeating. It's defined as follows. As n approaches infinity, of 1 plus 1 over n to the n power, we approach 2.71828182845.9. You don't need to know that. Right? You don't need to memorize the numbers of e. You don't need to memorize what this actually means. We do need to know that e is actually a number in this case, 2.71, 2.72. Alright? And we're going to use it as a base for one of our logs, and it's what we're going to call the natural logarithm. So, it is what we call the natural base. And a log that has a base of e is what we call the natural log. So in this case, the natural log is written as ln. I know it's kind of backwards, right? Natural log. But it basically means log with a natural base. So anytime you see log base e of x, we can change it to ln of x. And if you actually look on your calculators, I think it's right below the log button, there's an ln button. That's for your natural log. It's a log with a base of e. Alright, so, let me go down here. Log form, exponential form, same thing. We can change the natural log of x into an exponent if we want. Right? I would write it as, so if we have this down here, let's look down here. We have y equals the natural log of x. Right? That is the same as e to the y equals x, because if I have y equals log base e of x, if I switch this, these are the same, we just said that. Log base e and natural log are the same. If I switch this to exponential form, base of my log becomes the base of my exponent. What my log equals is going to be my exponent, and what I'm taking the log of is what it equals. So it works the same way as how we switched them yesterday. If I switch to exponential form, it becomes e to the y equals x. Now, it is okay as if you go through your problem, you write log base e of x, but you can never, ever, ever, ever have an answer that states log base e of something. If you have log base e, for your answer, it needs to be written like this. It needs to be written as a natural log. Right? Because technically, think of it as the simplified version. Does that make sense? Yes? No? Kind of. Alright. So, like I said, basically, natural log is a log with a base of e. Okay? So let's work with it a little bit. Let's flip to our next page. Let's work a little bit. So, types of problems. So how do we simplify expressions containing e? We use our normal power rules. Right? Like we learned last unit in exponents. If I have e squared times e to the sixth, I'm going to add my exponents, right? Multiplying things at the same basis, I add my exponents. It works just like any other exponential rules. We get e to the eighth. Same thing, e to the negative second times 3 e to the seventh. Well, multiply my whole numbers, 1 and 3, I get 3. Multiplying things at the same base, I add their exponents, I should get e to the fifth. Right? Just use my basic power rules like we did last unit. 2 e to the 5x, all raised to the second power. What do I do with that 2 on the outside? We distribute it to both pieces, right? We distribute it to the 2 and to the 5x. Well, 2 squared is 4. What do I do to these two exponents? Multiply. Power to a power, we multiply. So e to the 10x. Do we remember this from last unit? Yes. Good. I'm really glad you said yes and not no. Alright. 4 e to the negative second. Distribute the 3, right? We raise it all to the third. 4 cubed is 64. E to the negative sixth. I'm going to write my answer like that. No. No. Negative exponent means bring it to the bottom. 64 over e to the sixth. Keep going. Am I going too fast or are we good? Okay, let's keep going then. 1/2 e to the negative second raised to the 4th power. Same thing, distribute it. 1/2 to the 4th power is going to be what?
1 to the 16.
1 over 16, right? If I distribute both the 1 and the 2, I get 1 over 16. E to the negative 8th. Well, negative exponent means flip it, the denominator. 1 over 16 e to the 8th. Good? How should we do the next one? Square root of 36 e to the 4x. You could square root it, but do you know what the square root of e to the 4x is? No. How else can we write a radical? Not log form. As an exponent, right? The square root is the same as 36 e to the 4x raised to the 1/2 power. Right, so if I rewrite it as an exponent, then I can distribute it. 36 to the 1/2 power e to the 4 over 2x power. Right? You all follow what I did there? 1/2 times 4x is 4 over 2x. Or excuse me, 4x over 2. Sorry. Apologies. 4x over 2. 36 to the 1/2 power is going to equal 6, because it's the square root of 36. E to the 4x over 2 power is going to be e to the 2x. Right? 4 over 2 reduces to 2 over 1. 2 more quickly. E to the x over e to the 3x. When I am dividing things at the same base, I do what to their exponents? Subtract. So x minus 3x will give me e to the negative 2x, which we know we can't have a negative exponent. So we have 1 over e to the 2x. Lastly, 12 e to the 4th over 36 e to the negative second. Well, 12 over 36 reduces to 1 over 3. Remember, if I divide at the same base, I subtract my exponents. 4 minus negative 2 will give me
E6.
e to the 6th. If you want to just put e to the 6th over 3, that's fine as well. You don't have to put the 1 there. All right, any questions how we use e when we're using it in a problem? Right? Normal power rules. Normal exponent rules. Okay, let's keep going then. So, what would the natural log of e equal? How'd you get 1?
Put it in my calculator.
You put it in your calculator. Oh, you cheater. Alright, well let's think about it. The natural log. Natural log of e. We said the natural log is the same as log base what? The natural log is the same as log base e, right? We all agree. We said that earlier. Natural log of e is the same as log base e of e. Right?
Is that
Yes.
a B next to the log?
Right here?
Yeah.
That's an e. It's just really poor e.
Oh, okay.
Alright? So we said natural log of e is the same as log base e of e. Well, what did we say when I have a log base that's the same power as what I'm taking the log of? That was one of our special cases, right? What did we say it equaled? 1. Whenever my base is the same as what I'm taking the log of, it is going to equal 1. So that means anytime you take the natural log of e, it will always equal 1. Alright? I know this is probably really confusing right now. And this is probably one of the more confusing days in the unit because you've never seen a number that's e. Right? You've never dealt with a natural log before. Alright? So practice and repetition and asking questions as we go along here will be very helpful. Okay? Alright, so natural log of e will always equal 1. If it helps, guys, in the problems, change it to log base e. If that helps, right? Just make sure you don't leave your answer as log base e because it'll get marked wrong then. Okay? Cool? Alright. Then, how do I evaluate it in my calculator? So you'll notice, I said, there's a natural log button, right? If you look right above it, there's an e to the x. So if you hit second and then natural log, it pops an e out in your calculator for you, and you can put any number you want in there for an exponent. So if I say do e to the third and round it to 3 decimal places, what do we get? What was that, Alvin? 8.86. Good. Did everybody find the e to the x power button?
Yes.
Who said no?
I'm probably just going.
So did you find the natural log button? Right there.
As long as it works in the calculator,
Okay.
it's fine.
Okay, so do the next three. Do the next three. E to the negative 2/3. E to the, is that 1.7? Yeah, it's not very nice on the screen, is it? And then e to the 1/2. Lexi, did you do e to the negative 2/3? What did you get? Only what? Did everybody else get that?
Yes.
Sweet. 513, right? Round to 3 decimal places. Who else could put that? One of our Aiden's back there. Did you do e to the 1.7 power?
Yes.
What'd you get?
5.474.
Cool. Faith? Did you do the last one?
Oh.
Not yet? No. Okay. I'll pick somebody else. Ange, did you do the last one? What'd you get?
1.649.
Alright, did we all get those numbers? Did we all figure out how to use that E button in our calculator? It's going to come in handy when we're trying to solve things from the natural log. We got to switch to exponential form, and it switches to an E. So that's why we're showing you how to use it in your calculator, alright? Because we're going to end up solving now with the natural log and our natural base of E. Alright, any questions so far?
No.
We're good? Alright, the next thing we're going to talk about, right? We have a lot of things. We're throwing a lot of stuff at you today. So, next thing we're going to talk about is, we talked about compound interest last unit, right? We all remember this formula?
Yes.
We all recognize it, at least maybe not remember it.
Yes.
Okay, that means it's compounded, like we said, annually would be once per year. We said semi-annually was twice per year. Quarterly was 4 times per year, so on and so forth. If we want to compound continuously, that means it is, after it's done compounding, boom, compound it again, and again, and again, and again. It never stops. We're going to use this formula right here. It uses all the same parts as that original formula. The amount, what we want it to equal. The principal, what we begin with. Our rate and our time. The only difference is now it's P times E to the rate times time power. 8 per. Right? P times E to the R times T power. So we now know what E is. E is a number. It's a button on our calculator. Right? So now it's just rate and time and our principal still. Alright, so now if we want compounded continuously, anytime you see the word compounded continuously, we're using this formula. Any other compounding quarterly, monthly, daily, we're still using that formula from last unit. Alright? Is that written on there or no? Yeah, okay. I see some people writing things down. Are we good to try some problems? I think we're going to try solving with it. No. We're going to do compound continuously first, then we'll try solving. Alright, so we invest $6,000 in a comp, pays 3.5% annual interest, compounded continuously. This is not the right problem. This is the right problem. Alright, if you invest $5,000 at 3.6% for 10 years, how much do you have in the given scenarios? There's 3 scenarios. First one's compounded quarterly, which means how many times are we going to compound it? 4. So n equals 4. We're using that first formula, that one we learned last unit. P is 5,000, right? My principal, I'm starting at $5,000. My rate, 0.036. Guys, please don't forget to change that to a decimal. And my time is 10 years. So if n equals 4, I'm going to plug it into my formula. 5,000 times 1 plus 0.036 divided by 4 to the 4 times 10 power. I can hear you guys already clicking away at your calculators. So plug it in. Right, this is our last unit formula. Plug it in, see how much money would we have? It's compounded quarterly. Do we get an answer for compounded quarterly? Andrew, did you get?
7,155.
7,155
12.
and 12 cents.
Yeah.
Okay, guys, let's think about it before we start trying the other problems. That was compounded 4 times per year and added into your bank account. If I compound it 12 times per year and add it back in my bank account, should I have more money or less money? More, right? If they keep giving me more, they keep compounding it more, I should have more money. So this number is going to be bigger. And what do you think about compounding continuously? It's going to be even bigger, right? Because they're compounding it and adding money in at all times. So compounded monthly, we use the same principal, rate, and time, but now it's n equals 12. Right? Now I'm compounding it 12 times. So A equals 5,000 times 1 plus 0.036 divided by 12 to the 12 times 10 power. Who got an answer for that second part? I know I'm going really, if I'm going too fast, guys, slow me down. I assume we have a lot of stuff to get through. Sid, you got an answer?
Yeah, 7,163.79.
0.79. Perfect. Oh, did it hold true? Yeah, we got more money because we compounded it more. All right, our last one, compounded continuously. Well, we said that's our new formula where A equals P times E to the R times T power. A equals P times E to the R times T power. Or A equals 5,000 times E to the 0.036 times 10 power. And if you have an older calculator, I may put this in parentheses, my exponent. We're plugging it into that new formula we were given. Anytime it says compounded continuously, we need to use this new formula. Because that just continuously compounds it for us. It doesn't worry about how many times did we compound it in the year. It just keeps going and going and going. Alright? That table of 3 there, did you guys get an answer?
Yes.
Conroy, what'd you get?
7,166.65.
Point what?
0.65.
0.65. Thank you. Good. Guys, the big thing here is you're able to put it in your calculator. So make sure you're trying these in your calculator, please. Do we have any questions so far? Like I said, I know we have a lot going on today. I want to make sure we get through it all, so that's why I'm going so quickly. Alright? What time are we out here? 25. 15 minutes. Alright. Alright, let's run through the next one quick then. We invest $6,000 in an account that pays 3.5% annual interest, compounded continuously. So that tells me I'm using my new formula. We don't know how long it'll take for the balance to be $10,000. So A is 10,000, right? It's what I want it to equal. What's my principal? What am I starting with? 6,000. And what is my rate? 0.035. My time is my variable, right? I don't know. I want to know how long it takes. So I'm plugging it in. 10,000 equals P 6,000 times E to the rate 0.035 times time power times X power. Oh, how are we going to solve this? Divide by 6,000 first, right? If this was last unit, we'd punch in our calculator. But we know how to solve this now. So, divide by 6,000 first. What do we get as a reduced fraction for that? 5/3 or 5/3 equals e to the 0.035x power. Oh no. Now what do? I heard someone say it. Log, right? Guys, it's in exponential form right now. Change it to log form so we can solve. If I change this to log form, the base of my exponent, which is e, becomes the base of my log. So it becomes log base e of 5/3 equals 0.035x. Okay, now hold on. We said log base e is the same as ln, or the natural log. So I'm going to change it to the natural log of 5/3. Because what can I do with that then? What can I do with this? You can put it right in your calculator. Do we get a nice number? No, not right now. Should we round that non-nice number? No. But what we can do is we know we're going to have to divide by 0.035 to solve for x. So once you put it in your calculator, then divide it by 0.035, and now we can round it, because now we're finding what x is. So you take your natural log of 5/3, you divide by 0.035. Did it say what to round to? No, let's round to the nearest tenth. How long did it take us?
14.6 years.
14.6 years. Very good. All right. Guys, is there any questions on that? All right, we have a couple solving problems to do quickly, and we're going to get some work done. First one, solving using natural log. Guys, when we solve using the natural log, it's the same as using any other log. We need to isolate our log first, change it to exponential form, and then solve. Our first one, natural log of 4x plus 1 equals natural log of 2x plus 5. So what equal to each other? Yeah, 4x plus 1 and 2x plus 5, right? Same as yesterday. We have the same basis here. They both have natural log, so both of these pieces needs to equal each other as well. 4x plus 1 equals 2x plus 5. Well, subtract 2x. 2x plus 1 equals 5. Subtract 1. 2x equals 4, and then divide by 2. X equals 2. Right? Just like yesterday, if our bases are the same, we can set those parts equal. Alright, second problem. 16 times natural log of x equals 30. Step 1, isolate my log function. What do I have to do that?
Divide by 16 on both sides.
Divide by 16 on both sides. I'm left with natural log of x equals 15/8. Right? Then I need to switch it from log form to exponential. Ooh. It is going to be easier. The natural log is the same as log base e of x. I would rewrite it as log base e, because then when we switch it to exponential form, it's a little bit easier to do so, right? If you can go right from natural log of x to exponential form, do it. That's fine. But if you need to take this extra step where you change natural log to log base e, do that as well. Alright? So we change this to exponential form. Base of my log is the base of my exponent. What my log equals becomes that exponent, so 15/8. And it equals what I'm taking the log of. It equals x. Does that make sense? We're changing it from log form to exponential form. Just like we did yesterday when we were solving. We went base of my log becomes the base of my exponent. What my log equals becomes my exponent. But I think the log of equals that exponential. So I can go ahead and I can just plug this right into my calculator. E to the 15/8 power and we round to the nearest hundredth, we'll say. And what do we get? 6.52. Good. Guys, any questions on that? Alright, one last problem and I'll get you your homework. Natural log of 5 minus x equals 12. First step, isolate my log function. What do I have to do that? What do I have to do that? What? Nothing, it's isolated, right? My log function's all isolated over here. I'm taking the log of 5 minus x. So I'm going to change it to exponential form. Like I said, if you need to, switch the natural log to log base e of 5 minus x equals 12. Well, switch to exponential form then. Becomes e to the 12th equals 5 minus x. Right? Base of my log becomes the base of my exponent. What my log equals becomes my exponent, and what I'm taking the log of is what my exponential should equal. Okay, before you go and put e to the 12th in your calculator and start rounding things, right? It doesn't come out to a nice number. Leave it as e to the 12th until you're ready to put everything in your calculator. Alright? So what I would say, subtract 5. Subtract 5. E to the 12th minus 5 equals negative x. And do I want negative x? No, I want positive x. So I can either multiply or divide by negative 1. So then I would go to my calculator and put e to the 12th, enter. Minus 5, enter. Divided by negative 1, enter. And to the nearest hundredth, we see that x is let's see, who can I count on that did it? Renee?
Negative 162,749.79.
Good. Did we all get that when we punched in our calculator? Yes? No? Do we have any questions on that? Okay. Guys, that is probably the most stuff we're going to throw at you in one day. Alright? We threw a lot at you.